Hello, everyone. Welcome to another design review on the subject of our friend Tabular. And what are we looking at today?
Okay, so we need to wrap up the discussion about grouping. Carlo couldn't make it today, so he asked if we can wrap it up with him. And we have touching that. There's another problem that we need to address that I'm presenting here that is related to data cleaning because
Let's just remember what by grouping, what we're talking about is the ability to make use in functions of construct columns to make use of information that is not row-wise information, more global information, non-row-wise information.
It depends on the whole column, on values in the rest of the column. Or look at the rest of the columns.
And where had we got to last time? What we had gotten to last time was...
You can open it. There's the transform missing, and with groupings, they have all the notes. So, yeah, we spoke about operation, operator forms, and things like that.
Right. So, the main point here is that we need a way, as we talked about before, there is, these are row-wise operations, basically. Transform columns is fundamentally a row-wise operation, correct?
Yes.
Okay. So it needs a way to refer to things that are not row-wise, and in particular, it needs a way. How do row-wise operations, although transform missing might not be row-wise at all, but okay. Row-wise operations, like transform columns, refer to whole columns or parts of columns that are the result of grouping. Is that right?
Yes. There's other elements that are not so far away from applied, and the main one is the index. So that to me, the only connection we have with supply, given that you brought it up a couple of times, is to get the index of the row.
Wait. You're saying that there's a third thing here, or to the index, either within the column or the group, correct?
Exactly. And there's actually a third thing that Carlo brought up in his original prototype, which was the sorting. You group by...
I understand that, right?
Yeah.
Or the index with respect to some sorting, with respect to a by sorting, so to speak.
Exactly. Yeah. This was a full spec, let's say, the list of things to have.
What is the analog? When you say sort by, okay, so if I say sort by, if I say sort by this, and now I want to find where is the one in that. Is there a function that gives me the index?
Ordering by, do we have it?
Yes, we do.
Okay, so this is going to be that.
Well, let's take a look. So what is this really telling me? This is telling me that element is the third element. Okay, so we do in fact have a mechanism already for dealing with this with respect to a sorting. Am I making sense?
Yeah.
Yep.
Which is essentially an ordering function. Do we have? We don't have that, but we could have that. Okay. So now...
Right. As usual, we have the method of an ordering function, a two arguments ordering function, or the by function, a unary by function.
Yes. Yeah, fair enough. Okay. So now, all right. So let's just understand. Okay, this is for construct columns and transform columns, correct?
Yes.
This description. Now, transform missing, is that a different description of what we need?
Okay, I had my original idea was that transform missing would take a column spec, same as transform columns. Just not to confuse things too much, and also because it's really column by column typically. And then it would provide a function that tells you how do you find the missing element of that column, like a missing spec.
Right.
No, sorry, missing element. Sorry, how do you find what to put in place of the missing element of that column?
Right, I understand. But
yeah, so like the shortest thing would have been, A goes to mean, with the tacit assumption that you apply mean only on the non-missing element.
I understand. But so what's happening is the difference is that in transform columns, okay, that column-wise operations are kind of here, column-wise operations are the exception.
Exactly.
Here, column-wise operations are the norm, right?
Yeah. This is, I mean, the order of application, the direction of application is the one that we have in reduced tabular. Yeah, where you without the reduction. Yeah, but you get the transposed tabular in. Now, the problem with the missing transform is that, the point is, what's the added value compared to just using transform columns? And it has to be that the syntax is simpler.
Yeah, let's get to that in a minute. Okay, let's get to that in a minute. Yeah. I'm not totally convinced there.
Okay, but then let me tell you another thing that we need transform missing to do. So maybe we don't do it, but in terms of things, like some methods are constant, like mean, mode, or like commonness, or a constant.
Some of them are things like random numbers.
0. Random numbers, okay, maybe we find a way to do delayed. You can use rule delayed, and we can say that that is evaluated every time. That's one of the easiest. Some others are position sensitive. For example, you train an interpolating function.
I'll give you a much worse situation. I'll give you a much worse situation.
Go.
Which is that fill in all the elements of a column so that none are repeated. You understand what I'm saying?
Okay, so it's basically a random choice without replacement.
Well, right, but let's imagine that what I've got is 1, 5, 2, 8. Okay, with some missings in here. Okay, and I have a global constraint that I cannot have the same key twice.
The same value twice, I mean, yeah.
No, well, same. I mean, these will be keys. I mean, in the end, or something, right? It doesn't matter. You don't have to think of them as keys. They just cannot have same value twice, right?
Okay, but then you still need a rule about how to fill missings. So you cannot sample.
But okay, it doesn't matter what the rule is. What I'm saying is, it doesn't matter what the rule is. Just think about it. You can't do this locally. You can't do this row by row.
No.
Right?
Exactly.
But I don't know whether there are other methods that can't be done row by row. Do you understand what I'm asking?
No, I do. And this is why the moment we started digging into transform missing, we immediately fall back to transform columns, where you have this switch of looking both at the row and at the whole column.
Okay, I understand, but that's not what we do. But this stupid shit is still here.
Isn't transform, I mean, isn't replace missing sort of in place, and transform column adds stuff? Or at least moves it?
No, they can both. I mean, transform columns can be in place if the column already exists. And I imagine that transform columns is kind of the workhorse that we are going to use to implement most of this stuff.
You need to, well, I guess you need the anchor column, right? You need to.
No, I don't think it resets the ordering. Like if you have ABC and you do B goes to rule, B stays in place the way it's currently implemented. It's not appended at the end.
Well,
If this
that
is what
was
you're asking,
not
Itay.
how things stood a few weeks ago. Maybe that's changed, but
That we have a mechanism to put
This is
things
how
in the.
association works.
Hey, we have a mechanism to put things after the column. You know, we have this whole mechanism for addressing where we put a new column.
The anchor, yeah. You could say C, comma, B goes to rule, function,
Yes,
and then
that's right, because
it's appended
you've
at
got
the
the
end.
anchor. You've got the anchor
Exactly.
column specified
Exactly.
there.
But if you don't use anchor, that's the same semantic as association.
Right. Okay, let's get to what we need to do here, right? So, look, the basic point is, in a sense, this is, it's really a column transform missing is what we're really talking about. In other words, it's being fed, I think everything we do here, it needs to be fed the whole column. Am I making sense?
Yeah.
I mean, there
agree.
are
Mostly, yes.
I mean, there are versions of this. Maybe we wouldn't use transform missing for them, but there are versions which actually don't look at the column, right? They look at other elements of the row.
Well, why isn't that just?
But it's very rare because
columns?
of a type constraint.
Okay. Wait. Isn't that just transform columns? If they're
Yes,
row-wise.
If it's row-wise, you could use missing fallback. I don't remember what's the final name of that. You could use missing fallback on the row.
But also exactly what Steven says, transform columns. Look at the other parts of a row.
Yeah.
No, exactly. Yeah, I was expanding on that. So you use transform columns and you do B goes to missing fallback.
Yeah, missing fallback might be useful there, right?
And that is basically doing that. It's taking the first non-missing,
yeah, but that's a different operation. That's a separate operation.
Agreed.
The important point is that it's a row-wise operation.
Yep.
Right? It does not need to go missing fallback. Is purely row-wise. Right? So in other words, the big picture is transform columns does things row-wise. Okay?
Although, wait, how do we narrow it into the parts where we actually need to do it for transform column? Only the missing row, the rows that had a missing.
Well, why don't we just have an operation? I mean, why don't we say A goes to replace, or is that not right?
Sorry if I add it again, but I thought that missing fallback is exactly that function. It's selecting the first non-missing. So you can say missing fallback, like A goes to missing fallback of A, comma, the rest of the row. And if A is non-missing, it will stay A. If it is missing, it will go, among the rest of the things to pick them up, and you can put them in a specific order if you want.
But that's not dealing with a different issue. That's not dealing with the issue of minus 99.
That's pound A, comma, pound whatever. Right?
Yeah.
In there.
Yeah, pound A, comma, pound B, comma, pound C, and that is using the rest of the row, in order. That is like selects first of a non-missing element of that, and that's it.
Well, that should be a list, right? It's a list, correct?
No, we decided this to be a sequence.
This is something that while implementing stuff using this, or like prototyping syntax is using this. One thing very convenient would be to automatically sequence out lists.
Automatically what?
Like make a sequence out of a list here.
I don't think we should have sequences in here. I don't think we should. I think we're going to need options to missing fallback. I think it's a huge mistake to have a varargs thing.
Okay, and should we flatten a list by default or no?
I don't know. Probably yes, but I don't know for sure.
Because a great syntax would be list of hash A. For example, let's say that you want to take the first non-missing element in the column. Yeah, you do hash A, comma, some syntax to extract the column A.
No. Wait. You're mixing things up. Okay.
Okay. Yeah. You're right. But okay.
You're mixing things up. This is a row-wise operation. Okay.
Yeah.
So, I mean, basically, let's imagine that what you want to do. Okay, so there are two basic things. You're either falling back onto a different column, which is transform columns missing fallback.
Exactly.
Okay. Or you're looking column-wise. And I mean, we're making the approximation that everything is rectilinear. You're either looking row-wise or you're looking column-wise. You're not looking at blocks of this and that, which have both rows and columns. Am I making sense?
Yeah, in the general thing, you could be doing that. And this is how we started reasoning about
If
it.
you want the
but
general
let's
thing,
do
you
it
can
one
take it
step
out
at
as
a
an
time.
expression. You can do whatever you want with it.
Mhm.
Fundamentally, transform columns is doing row-wise stuff with an escape valve to pull in whole columns. Am I making sense?
Mm-hmm. Mm-hmm.
And what would that look like? In other words, let's say we want this thing, and let's imagine that we want the missing fallback here to be the by the way, assume missing fallback is a function that takes the values that it encounters on that in that column on that row.
Well,
in other
no,
words,
it's a missing fallback is a function that is applied to arguments, right?
No,
You
I
can,
understand.
and I believe it's implement, right? It's black, so you can just do,
Yeah.
right? 2 comma miss, 2 3, no 2 comma 3, and you'll get 2. No.
It evaluates.
It returns the first non-missing thing, so that gives 2, and then if you do missing fallback of missing bracket of 3 comma 3, then you'll get 3.
Exactly.
Okay.
So, for example, I'm putting something in the chart here.
Wait. What happens
Oh.
with evaluation? Is this something that is controlled evaluation so it doesn't evaluate the 3?
Right
You
now, I
understand
don't
what
know,
I'm
but
asking?
it should. But it should. I mean, I think we should fix this. This shouldn't evaluate, I think.
Well, okay. So if that's the case, that's something of an argument in favor of a Verargs version. Am I making sense?
Right.
Do you understand what I'm saying?
Yes, I do. I do.
Do you have a comment on it?
I'm thinking about practical use cases. In Tabular, I don't imagine many delayed values in Tabular columns when you pull in data, like real world data.
Right.
You're going to have like strings, numbers.
It depends on whether it's an expensive operation. If it's an expensive operation, you don't want to do it unless you have to. Like, for example, let's say that operation there is to do some anomaly detection on a column. Do you understand what I'm saying?
Yeah, you don't have simply hash column. You have function of hash column.
Well, no. It's just you don't want to do that operation unless you need to. Unless
No,
Well, what do you mean by that operation?
The 1 plus 1 in this case.
Right. Yeah. Don't be silly, Julio. My point is that when you said half of a f of hash column, right, you were representing some general operation on a column.
Yeah. I mean,
Right.
because to me, when you do it in transform columns, you're always talking about columns.
Be clear. Okay, look. So we've got the issue of right now, this is all row-wise. Okay. We talked about last time the, how to represent pulling in a whole column or the grouping section of a column. Am I making sense?
Yeah. And the thing we didn't resolve is where do you put the grouping spec? Okay.
So.
And that's the thing that, Carlo asked that we postpone until he's back.
Exactly. Exactly where we put the grouping spec.
Okay. We're doing this now because we're doing this now. We're not going to wait because you wait and we'll all have forgotten how this works.
So one thing I put in chat is exactly this operation without the grouping. Is that with row and column is exactly what you're talking about, Steven. There's nothing separate. Yeah. Now, like here, I put at least
Yes,
because
but
we were
but
discussing
I know,
about,
but we didn't want this. This isn't going to work. Okay.
Okay, I wasn't
This is
super
not
sure we
what we
dropped this
want.
completely.
What's that?
I wasn't super sure that this was nixed, completely last time. Okay.
Okay, but what we want, this is just absolutely horrible.
Okay.
Right.
Why is this super horrible?
Because it's a total hack. Let's think about what it is we're actually trying to do. Okay. So we've been given an association. Okay.
Mm-hmm.
I don't understand. Okay. So the issue is we need a thing here.
I have an idea.
Yeah.
So missing is a little bit like a categorical column. Okay, it's basically a binary vector, a Boolean vector that says if something is missing or not. What Carlo talked about is group by, which is using categorical columns, but they're all effectively categorical columns. The missing is just not there explicitly. It's sort of stored underneath because it's a property we need to know.
Yeah, yeah.
So if we had for transform column a way to home in on the sections that we need, whether those are missing sections or categorical value sections.
In other words, you're saying a grouping by missings in column C or something.
Yeah, for instance, exactly. And that way,
the missings, so to speak.
That why, so one of the things that would allow us to do is kind of just drill right down to the things we need to transform and not deal with all the others and have fallback and all that stuff.
I don't think that's right. I mean, that's not what the fallback is doing. The fallback is row-wise.
Yeah, but you let's say that
Well,
you want
the fallback is nothing, right? The fallback is just a normal function. That's like saying that plus is row-wise, right?
No, but it's applied to the association. This function is applied to the association that contains the elements of that row.
That's only because that's the right-hand side of transform columns, right? If you did missing fallback, I mean, it would be a stupid thing to do in a, in delete missing or transform missing. But if you did that in delete missing, it would be applied to the whole column, right?
Yeah, okay, you're saying missing fallback. Okay, but the important point is, okay, because by we have the convention in a sense that you put things like hash A and hash B, which pull out elements of an association because the thing it's typically being fed is the row which is represented by an association.
Yep.
Okay, so let's come back then. The issue is every so often we might need to gulp in the whole column instead of just this element, right? That's the main thing we're trying to solve, correct?
Yep. This is what I put in that syntax. What you
Yes, I know. I realize.
Yeah.
I know. And one of the things that's confusing is that transform missing generically takes whole columns. It does not typically want to refer to individual, row elements.
I don't
Right?
Yeah,
think
typically the
only
method is
looking at the
row-wise.
that's
missings.
true, right? I mean, if it's some sort of local, take the
But it
average of
isn't.
the nearest non-missing
But it
thing.
isn't.
but it isn't, Itai.
It isn't. It just isn't. I mean, this thing, its name is confusing and probably wrong, but fundamentally what it's doing is it's gulping columns and processing those columns. Am I making sense?
Yes.
Yeah.
Yes. So an idea that Rob had suggested is a column-wise that is a wrapper to the functions. And so that function will now receive full columns. Hash A will refer to the full column.
Yeah, well, I was
Whatever that-
thinking about that. I was wondering whether we could do something where we say, is that possible to say column-wise hash A that gets us, just like element-wise is getting us just the single element.
Right.
Well,
Yeah.
why is that
I
color
think-
black?
yeah.
Does that have some current meaning?
Yeah,
Because
it
Rob
is
has already
implemented.
implemented something. Yes.
It is implemented as a headdress. So you do column-wise mean of hash A. But
Exactly.
Steven didn't like that change of that thing.
So this is a function wrapper.
Like element-wise is.
Exactly.
That's not completely crazy. But I don't know what it means because this is, oh, I see. That's,
So for example, in construct columns, we could say the name of the new column, a row, and then this, which is an operation on columns.
but I don't understand semantically how that works because normally
For
the
example,
function, go
rather
ahead.
than mean, think of accumulate. So accumulate of hash A. So change
Yeah, but I don't
mean here
understand
it's
how this works because isn't the function in transform columns simply fed the row, aka
Yeah, exactly. This is the thing that you didn't like. But element-wise is not changing its argument. It's changing the semantic of the function on the arguments. Column-wise
yeah.
is actually
But
changing
maybe
what hash
what we
A
should think
means.
about, I understand. Maybe what we should think about is, maybe the way to think about it is this, that when we say A arrow F, okay, that the true thing that's done here is that F, okay, let me try this out, okay? That it's more like this, that F is really given the whole tabular, the index. I mean, conceptually, it's not how it be implemented, okay? But conceptually,
Mhm.
it's given the whole tabular, the index, and this specific thing here. And
I'm confused because this way F gets a cell.
What?
Tab I A, that's a single value. Yeah, it's row I, column A.
No, I mean, look. Oh, yeah, you're right. You're right. It just gets this. Yeah, it just gets that.
Exactly.
Right?
Exactly.
That's what it gets.
Exactly.
So in other words, that this right now, okay, so that's what it normally gets. But let's say that there's a function g that is the function that determines what it gets. Okay? And normally that
Mhm.
function g is, normally it's just hash one, the table, or even hash tabular of hash index. Okay? That's
Okay, I
its
see
default
where you're
value,
going.
right? And then, so that, for example, it would look like this. So,
Okay.
you see what I'm saying? So that then what happens is, let me think if this works. So let's imagine that conceptually, the function g gets an association that's the full tabular, the index of the row, and the column that we are currently dealing with. Do you see what I'm saying? And it could get other
Mhm.
things as well, like, a grouped column or something like this.
By the column, you mean the full column or like A, the
No,
string,
the
the
full
column name?
column, the full column. The column, that would be the column. Okay, so let's write out what these things are. Okay, that's just the index, and the column would be tab of,
All A.
well, yeah, in this form, all comma A,
Mhm.
right?
Mhm. Exactly.
And by the way, we could also, as a courtesy, we could also provide row here. Whoops. See what I'm saying?
Which is tab I.
Which is simply tab I, yes.
Tab index, yeah.
I think this is not completely stupid. So let's take a look at what this would look like if you want to do something on a column, okay?
Yeah, we should write it because I think this is powerful, but might inflate the syntax.
Well, let's take a look. Let's take a look. Then we can, once we have something which is understandable, right?
We can simplify it, yeah.
Right. So now that let's see.
I mean, one simple operation you might want to do with this syntax is subtract the mean of the column from each element.
Okay, fine. So let's do that. So this is hash A, but that's not good enough. So what we've got here. Oh, I see. I see. Look at what this looks like. This is actually fairly non-stupid. Okay. So
now, first choice, do you want to put in a sequence?
Wait a second.
In a list? Okay.
What? Wait
I mean, how do you spread out things in a list, in association?
No,
or
no. What you've been given, this function here, maybe you want the whole thing. I mean, that function is, okay, so let's imagine here, it goes hash row sub hash A, comma, hash column.
And
this goes to hash 1 minus mean of hash 2.
Okay. With the caveat that we just signify that the list is provided as a sequence. I mean, now the function is applied on that.
What do you mean it's applied? That thing returns a column.
No, but the whole thing returns a rule,
a list, right?
It's a list, yeah. And then you're using not hash part 1, you're using hash 1. So there's some hidden application somewhere to make it work.
Yeah, okay. Fine.
This is what my original question about how you spread out the arguments.
Fair enough. I mean, it's a little bit overbearing, and you might wonder why we couldn't just say mean of hash column here, which is what you're kind of doing here. Except you don't need the C there.
Yeah.
I mean, that's this column. If you want a different column, that's a different story. I mean, you know, it's conceivable. You know, it's conceivable that if we had this syntax as the full form, that we could get away with some cheap syntax where we have hash column in here. And if you were using, you know, column as an explicit name, you would use the longer syntax. I'm not sure. But now I don't understand. In the case of transform missing, the problem is that the default is to use the column. Am I making sense?
Yeah. Yeah, I mean, it depends on where you start. Yeah, the problem in transform columns is how do I get access to the full column to implement operations. In transform missing, that's easy. So if you want to do a random choice or a mean or whatever, it's super easy. The problem is how you do something like what I wrote here. You know, like I want the index and I want to just check from this point forward the first node missing, something like that. So this is why we ended up writing those string methods but you suggested that we think harder about how to avoid them with the good syntax design.
Right. All right. Well, I think we've crisped this up a bit. So maybe we can.
I mean, one
Go ahead.
drawback to this is that, the functions you will now typically use will not have, well, I suppose if you in transform in transform column, right, your function names, as long as you stick to the default, which will be list of pound row, right, then you can use functions that use the names of the columns. If you're in transform missing, now you'll need to use sort of function names that are in slots or something, but maybe that's already a problem for transform missing. I'm not sure.
Yeah. I mean, look. Okay. I'm not sure this is quite right, but it's at least clarifying what the issues are, and it is giving us the opportunity to have lots of different cases for what you actually provide to these functions, given that there's a simple case where you're just doing it locally. Am I making sense? Missing
So,
fallback would be the common case.
Yeah, I mean, in this setting, the difference between transform columns and transform missing is that G is different, basically. It has a different default G.
Yes, that's right.
If you want to recast it in this way.
Yes. Yeah, I mean, in the default here would be that this is merely hash row.
Exactly.
Well, the alternative here, seems to me, is to have a symbolic wrapper that, for example, would be, so this is alternative, would be something like A goes to we need then a contextual hash A minus, and now we want something which is essentially a local, it's very much like supplied. Very, very much like supplied. It's something that says, whole tabular, because it's like a self of the whole tabular. See what I'm saying? Do you understand what I'm saying?
Yeah, but I don't understand why this is not column wise again.
It's not
Maybe
column-wise because
with a
column-wise is a
different
wrapper.
semantic.
Column-wise
No, I know,
is a
I
wrapper
know what it
for
is
a
now.
function,
I know what it
and
is
it's
now.
not.
But do you remember,
It's
Jose,
not.
why Rob suggested this specifically? Because another idea I was toying with for column wise is that it's something that changes the meaning of hash. By default, hash is in transform column has a meaning. In the part of the function wrapped by column wise, hash is like reduced tabular. So would be mean of column wise hash A, that suddenly you get access to the whole column of A.
I know, but it's not the right name. You understand what I'm saying? It's not the right name because it's not. Look, I mean, this could be, this could be, I don't know, this is what this does, right? That's what this does.
But why A string and not hash A? I would still like to use slot
because
in
it's
there.
not the right thing. Because it's not the right thing, right? Because this is the way of accessing that column within the whole tabular. Do you understand what I'm saying? Right. That's what. Am I misremembering?
No, I understand. I think we are okay. I thought we were thinking something. We were thinking about something similar, but we are thinking about two different things. I was thinking about something that blocks the slot in a different way. You are thinking about
the right thing to
something
do.
that
I don't think it's the right thing to do because I think that that slot, the slot is already applying itself to the association that is the row. Do you see what
Okay,
I'm
you say
saying?
it's inside the function, so it's too late to change the meaning of slot.
That's correct. It can't escape. And
Okay.
the only way to have it escape is to use supplied.
But then we lose the core meaning of the slot, which is the row, and then we need to manually specify what the row is, or use that reserved keys that you didn't like.
Right, but no. Supplied could do this, right? Supplied lets you get, supplied could get the column here, okay?
Mm-hmm.
Because it can get external information. That's the whole point. Supplied gets
No, true.
contextual
But then
information.
But then hash A becomes hash row part A. That's or hash row function A.
No, it doesn't. No, it doesn't. This is just supplied is providing.
Oh, you're saying not for the whole function, only for that part with the mean.
Look.
I see.
Yes,
I see.
yes,
I see.
yes,
I
yes,
see.
yes.
I see. I see. I see.
Well, I'm not sure that's right, actually. I think this has to be no.
Okay.
This isn't a mess because this has to be not good because supplied is for the whole function, but we have to pull pieces. Well, maybe that's a problem with supplied.
Yeah, I mean,
you know
okay.
maybe that's a problem
the
with
question
supplied
is
in general. Maybe
exactly
supplied in
is
general.
supply working at any depth or only at top level? Maybe that's a question.
Well,
for
it has
Itai.
only been
Doesn't know.
working
Supplied
at
only
top
works
level.
at supplied has to be the outermost wrapper. It tells you how to
Okay.
bind these extra things to the functions that you're going to give.
Right.
Okay.
So, I mean, an alternative approach.
No changing the meaning.
An alternative approach would be that one could say supplied of, ABC, whatever it is, the things, and then the function here could contain let's say
Yes.
something like that. In other words, so that it's not, so that it's instead of being a thing where you change the whole function setup, you're merely providing something which is then accessible. Although then you might wonder, why do you need the supplied to begin with? Why don't you just have something that reaches out? Like, for example, if you were doing map, you would say map of, f of hash, comma, why couldn't you just do this? See what I'm saying? Which might be
so
more
like a fancier version of a dollar transpose without the need of being tied to an argument itself. Yeah.
Where supplied element refers to the map. I mean, I don't know, maybe that's not right because you really want to be able to see, because what happens if I said, 2 plus supplied elements, I mean, that has to work, obviously. So what it would have to do is it would have to scan that, I mean, in other words, every function like map that has supplyable function arguments would have to scan its function arguments for supplied elements and replace
you cannot do it. It has to be done runtime, because it could, our evaluation semantic is too rich.
Obviously, it's done at runtime.
Okay.
Right, but it can be done somewhat efficiently, I think.
Mm-hmm. Yeah.
But that's, I mean,
I don't like this direction of supplied at all.
Why?
Well, because the current design, I mean, there is a mode where you scan for things, but the basic design is, you just continue using the functions you've always used, but you can now add more stuff. And this is sort of breaking that.
Why?
Yeah, you can use the functions you've always used. This is just a way of inserting additional environmental information. I mean, look, this is like, okay?
Right. Well, basically, you're forcing any use of additional arguments to be lexically inside. So if you've defined a function, you can't
Yes, this
use
will be
it,
a
right? With the-
lexical thing. This will be lexical. But it's a little bit like saying, putting stack in there, although that I agree is dynamic.
No, but why it has to be lexical? I mean, like it's something like block, yeah. Like the value of supplied is block to be that.
With the current design of supplied, right? You can define, f of xy equals whatever, and then you can do supplied of, give me these two things of the supplied, comma f.
Mm-hmm.
Right? But you can't do that with this design.
No, you're doing something slightly different. This is assuming that the things you're adding in the supply world are kind of add-ons, right? Whereas the current supply
No,
design,
it's more than add-ons. It's that you're going to have to write the function inside of map.
well, only if it's lexical.
But how can it not be lexical when you need a literal supplied element inside of it?
You don't. I mean, this could look supplied element at runtime. Okay, if supplied element was prepared to crawl the stack effectively, it could find what it needs. Maybe.
But you're
Okay,
still not telling me how. If right now I can define, f of xy equals x plus y, right, and then do, supply. Well, I mean, assuming this were actually implemented, but if it's not, but supplied of, list, whatever.
Can I just make a point about how this would work? Okay, let's imagine that what map did was that the map's effective semantics were, map of f comma x would effectively do block, every time. I mean, in other words, what it would do is instead of just saying f, it would say block. I'm writing this out in a fake way, okay? Right, equals 4 or something, SE of whatever it is equals. I mean, this is obviously fake, but you get what I'm saying. Comma f of x. Right? If it was temporarily binding supplied element things, then you could pick them up dynamically inside f.
No, I mean, that's just right. I mean, actually write what I was telling you to write, right? Map supplied, open list, content, comma, index. And those are strings and initial caps. And maybe content is something else, but
yeah, okay, but body, whatever it is, yeah.
And then F.
Yep.
Right? That works. This cannot work if you need to have a supplied element inside of it.
I don't understand. I mean, in this, look, this here could be
F is F, right? F is, #1 plus #2.
I understand. So it's a different thing that, okay, you're assuming different things about when you want to insert the index.
I'm not
Yes,
assuming, I'm
yes,
asserting.
you are. No, no.
I'm
You're
not
saying,
assuming. Stephen, let me finish my sentence. I'm telling you that we designed it so that you could take any function
I know,
and just stick it inside of
so
supply.
I'm saying, maybe we should reconsider that, because I think that being able to say that would be rather convenient. In other words, I can add that in. If I initially have f of #1, and then I say, oh, by the way, I want to add something about the index, I don't have to rewrite f. Well, I mean, I have to.
Well, hey, with my current with the design we had, you don't, is exactly the point. You have to rewrite f because you need to stick the things in there literally and stick.
Yeah, I
you
know,
have the ampersand.
I know. But as I'm thinking about it, and I don't know for sure, but as I'm thinking about it, this might seem, I had not figured out that this could possibly work, right? But this seems potentially more convenient than this. Because let's say I want to write map indexed, okay? I mean, map indexed would be map of supplied content, comma index, just like that, right?
Yep.
Correct? But let's say I mostly want,
Well, it would actually become a part, not index, but
yeah, okay, fine. I don't know. Anybody else have an opinion about this? I would like to look at this some more, okay? Because we, clearly, I'd like to look at this some more but let's go back to this, because what we're saying here is that you need access to the whole tabula, right? Basically, that's the fundamental thing.
If I need to be, picky, that's the transpose tabula for your syntax here. Unless you
Fine.
want to write again all.
No, fine.
No.
Yes, I got
I'm
it.
saying this because we always end up with this issue
Yes,
here.
yes, I understand that.
Sorry.
But my question is, I mean, it really isn't a hash anything. It's not being applied to anything. It's just a function that is, it's just a symbolic thing that has to be recognized. In other words, we basically have to scan these functions here, right, to see whether there is a whole tabula there, just as we'd have to scan it for those special hash objects, because we don't want to create them like with handler functions. We don't want to create them unless they're needed.
Well, I mean, this case is a pointer, yeah. I mean, whole tabular, it points to tab while you execute the function.
I understand, but you have to set that, and that's fine. But I mean, this seems like it would work. This seems somewhat uncontroversially, it will work, and it gives you all the flexibility you want. If you want to do all kinds of grouping things, et cetera, you just redo them. You just put them in right here.
Okay, so it's basically it's like having tab but anonymous.
Yes, that's right. You could equally well write this by having set tab equals tabular and then do all this stuff.
Exactly, but this way your function is independent of the actual input of transform columns.
Actually, this isn't right. Well, wait a minute. I mean, the problem is, no, actually, this is okay. This is okay. I'm sorry. I'm just trying to think about, you've got access to two types of information. The local row information that you've been given an association that you can index into, and the global tabula that you can index into and get whatever subpiece you want, right? I think this is the right way to do it. Comments? Roger, Christopher, anybody? Jose?
I was thinking that this feels like a column slot. Instead of having slot A, it's like a different type of slot.
We did talk about that before, but I think it's more flexible. I think that's, well, I think it's more flexible to just have, to just give you the whole damn tabula, because you've got all these operations that you can do on the whole tabula to do with grouping and sorting and this, that, and the other. Otherwise, we have to come up with kind of crazy secondary syntax for all that stuff.
So actually, a few questions. So the first question is, when you if you have if you have a pure function and you pass it an association of the first argument and then some other arguments, you can access the keys. Can you access the keys of the association with hash A, hash B, and then can you access the later arguments with hash 2, 3, 4, etc.? Like, can you do both of those simultaneously?
I don't think so.
Okay, well, I guess then
isn't hash A? Well, let's look at that. I don't know.
You can
so
try.
You're saying, yeah, hash A. Let's do this. Hash A, hash B, hash.
And then maybe hash 1, hash 2. Yeah.
Oh, beautiful.
Okay, yeah, it works. So, okay, so two things. The first thing is, it seems like the most like conservative way we could do this is just by having hash 2 be the whole tabular.
Yeah, that's a good point.
And then the next part is if we want to be a bit bolder and have some whole tabular or something like that, then well, okay, then the first question would be, are we going to get ourselves into trouble or something because now we have to traverse the input
Yeah,
function?
you're right. This is the trivial way of doing this. This is the trivial solution.
The only problematic thing with this
Well, yeah, which
is
is
that
more or less
so
where
far
we
we are.
started 2 meetings ago.
I mean, this whole thing we have right now works also with for symbol with down values.
What?
If suddenly we have
What are you talking about?
the function, like let's say a goes to hash a. That could be also a goes to f, and that then f is look up a or whatever. Yeah, but then
But then
we're in real trouble if we can't support a whole. You can't have it so that in the body of f you make reference to some whole tabular or some special tabular slot thing, right? Because then when you pass this f into this tabular function, it has to traverse all the down values to the core of the earth.
Okay, so Christopher, you're saying whatever solution we find, we can never support symbols here. Only pure functions.
What the hell? What kind of a symbol?
So Stephen,
no. I mean,
wait. Yeah. Why can't you use symbols?
Yeah.
The point is, then you need to define all your functions to take 2 arguments, not 1, every time you use transform columns.
Yes.
Wait a second. You're saying that if we give, the problem is that if we have a function f.
Let's do the classic +1. Yeah.
Hold on. To which we provide that. To which we provide half f of hash a. And then we give it 2 arguments.
Exactly. That will topple over because there's no pattern for 2 arguments. There's only pattern for 1 argument.
Well, no, sorry. So this pure function will work, but you couldn't just say f.
Fine.
Yeah. The point is you'd have to write f of hash 1 as opposed to just f.
Right. Well,
there is an option.
But I mean, isn't this? I mean, don't we need to have the pound a there anyway in order to?
No, look. The problem is this: that if we say f here, that f needs to expect 2 arguments. If we defined f of uv, f of u is blah blah blah, and then we feed it f of this, it's going to fail.
Right. And so I think that the point, so maybe one question would be, so are we expecting that most of the time people are only gonna, right, like if I have my my function f, and most of the time am I going to be applying it only to a particular column?
They're never going to care about the second argument. They're never going to care about the second argument most of the time.
Well, no, I'm talking more about, are they going to care about the whole hash 1 or only a hash a? Because if they're only ever going to care about the hash a, then it's pretty reasonable to write f of hash a. But if they're going to care about the whole hash 1, yeah?
Right. See, I just don't understand what the problem here is, right? Because if you, as even ignoring the whole conversation we've had today, can you currently do pound a goes to f? And if so, how does it know that it's going to apply that to pound a and not to?
What are you talking about? Pound a? There's no pound a. It's f. A goes to f. Okay, if you do that, it will apply f to the whole association, which I admit is probably a rare case.
Right. Exactly. And so I don't see, right, in the typical case, you're going to explicitly have some, pound A's in there or pound whatevers,
Yeah.
And
So it's a
so,
good point. So it's not the whole row. And so if you are going to use the whole row, you can know that there are actually two arguments there, the row and the transpose tabular.
yes.
So there is an option in dataset which is called item display function, which is designed in exactly this way. So it takes an object in the first argument, the position in the second, and the whole dataset in the third. And what it does is that if you just pass something that doesn't have the function head, it ignores it. A symbol will be ignored. So people will not suffer from these things. So you really have to
Wait,
pass
sorry,
something
what do
with
you mean
head
it's
function.
what do you mean it's ignored? Like as in you have to pass something with head function or it complains or
Well, in that case, it's a typesetting option. So if you just say item display function
yeah.
goes to framed symbol, it just doesn't do anything. But if it's function of framed hash, then it does something.
I mean arguably it should maybe complain if you give it arrow framed, but sure.
But
Yeah.
perhaps I'm just saying what we would do there.
Right.
Well, I
And
think
so-
provisionally that this hash2 thing is a solution. It's a nice, simple solution.
Gate that behind an option,
I'm sorry?
like handler function. So we have handler function keys, yeah, that
Yeah,
creates.
we could do something like that if we really had to, but I doubt we'll have to.
Mhm.
We are basically at time, although I think we have achieved a fair amount here. Now, I don't know exactly what, we could have transform missing. Well, we haven't really talked about transform missing because it generically operates on columns, and maybe it's the exact same deal. It generically operates on columns, and hash1 is the column. No, because you're going to need functions that individually that just so transform missing. Oh boy, I mean we've got these columns and then we've got grouped pieces of the columns and so on. I think we need to look at transform missing another time.
Mhm.
And that's okay. And I doubt transform missing is the right name. I don't know what any of this is, but we didn't get to it today. What were you going to talk about here?
This is so when you deal with missings structurally, yeah, you might have specialized columns like transform missing, but in general, for Tabular, we want ways to isolate, take, drop elements based on not just on indices, but on values. For example, a common way to find outliers is to find elements that have they are more than 3 standard deviations from the mean.
Yeah.
Yeah. So how do you do that? Here, I propose different syntaxes to make sure that we cover our angles. So right now, and I have to do it with insert columns because of the this impossibility of dealing with columns. I take a tabular, which is a random thing plus that number 20. So I have a manual outlier, and I create that and I put in a tabular, which is a column A. It's a single column with one outlier.
No, I'm not paying attention. I'm sorry. I'm
Okay.
distracted because we ran out of time, and I've got.
And then we're gonna do this next time. It's fine.
Right. Sorry. We made progress. So let's
Declare victory. Yay.
Huh.
As we made
for
progress.
now. Yep. Sounds good. Okay. See you all
Okay.
soon.
Bye.
Thanks. Bye.
Bye. Bye.